Good afternoon, everyone. I appreciate you all having me. I hope everyone's enjoying the AnyLogic Conference. Thank you, AnyLogic, for allowing me to present. Um, I am George Miller. I'm with MOSIMTEC. I am a simulation consultant. I've been working with MOSIMTEC for a little over 8 years right now. My background's computer science, and in a lifetime before, I was a software developer. And here I am to present a project I did and partnered with Wolverine Terminals. Unfortunately, my co-presenter, Jesse Salas, is unable to attend, but Jesse was an important piece of a puzzle of getting this project completed. And he's helped me to put this presentation together. So I'll do my best to kind of represent Wolverine Terminals. But yes, navigating success, validating throughput capacity in a novel marine operation through just event simulation. Allow me to introduce MOSIMTEC, a little bit about us. MOSIMTEC is a global leader in business modeling and simulation and digital twin consulting. We were established in 2011, and we're headquartered in Washington, D.C., focused on modeling simulation and data management, and provide data analytics and visualization, consulting, advisory services, software sales, and support training. We're an AnyLogic partner, and in fact, we've lucky enough to be able to present at AnyLogic conferences in the past. As noted in the middle of your screen, we in fact have another presentation. My coworker, Jeff Skipton, who'll be presenting later today. So please be sure to check into that. Thank you all. And allow me to introduce Wolverine Terminal. Wolverine Terminal is the partner we had presenting this specific project. They are based in Calgary, Alberta, specialized in providing marine fuel solutions in Prince Rupert on Canada's west coast. The port of Prince Rupert is currently the largest port in North America without marine fuel service, and Wolverine Terminals was tasked with providing that service. And in doing so, they patented a barge technology to allow for rail offloading and marine fuel blending on a floating barge. I started this project with Marine back in October of last year. So they had commercial operations expectations to commence in this quarter for 2024. I know that they are currently finished completion on operations, and they're in the middle of beginning kickstarting their operations at the moment. So hopefully I'll hear more about how that's going, and as we work alongside Wolverine to get the latest and greatest from them. So let me give you a little bit of background review. So once we partnered with Wolverine Terminals, they wanted to develop a discrete event simulation, and they want to study the throughput capacity of their new complex marine fuel business. They wanted to have the ability to evaluate and test assumptions for the system, given different demand, supply, processing, and environmental variables. The primary objective was to stress test the maximum volume throughput capability for the entire system, and we used simulation model in AnyLogic to do so. They had secondary objectives. They wanted to understand certain system constraints, capture any bottlenecks, and identify any optimization opportunities along the way. The image that's depicted here, you can see denoted by the 1, it's actually the Canadian National Rail terminal that connects with this system, where it will connect with the Wolverine Terminals marine fuel service site. So how did we help Wolverine Terminals? We had to go along a journey with them, a navigation to our success with our simulation. MOSIMTEC prides ourselves on providing a blueprint for any of our projects for simulation, and it was no different when working with Wolverine Terminals. Working with Jesse, we were able to, where you see in your upper left-hand corner here, where we started on requirement specification, FRS, where we documented, described everything that we wanted to capture in the model, going from the design and modeling approach, how we expect to take inputs for the model itself, and expected to display outputs for the team, the Wolverine team. At this point is when we took a fork in our pathways, where the upper region is where MOSIMTEC continued. I personally continued model development after we agreed to FRS, and iteratively developed a series of milestones to, create the model's architecture, define the objects, algorithms, model logic, and reporting. And Wolverine went along their way of collecting the data into the format that we agreed upon, so that they could extract and transform and load it into a data mockup that we provide for them. Once we completed our model development, we were able to make sure that the model was working without error. And then we worked together with Wolverine Terminals as we kind of converged at that validation point and had this process of determining the model accurately represents the system. We use very specific inputs to test the model to make sure that it behaved the way we believed it should. And before we started using the actual data set and came to a on a baseline for the model itself, then we took the baseline a step further and came up with another series of what if analysis adjustments or toggles to the model so that we could try different scenarios. And then we gain insights from the model from all these different scenarios and analysis, and we're able to deliver a presentation to Wolverine Terminals and them come to the best conclusion from the outputs of the model. Now, integration and change management wasn't actually used in this project specifically. Sometimes some of our projects require some data connection or live connection to a server of some sort or to process the data and continue to have it retained for future use. Ongoing analysis and support, we provide Wolverine Terminals with necessary interface to use in the model so that they could change and rerun the model itself as they saw based on what we came up with the FRS document to help ensure that they can continue to use it as they took ownership of it. And we expect to have a further engagement with Wolverine Terminals in the future. As I mentioned, the operations are now live. We expect after some time when they collect the data, another discussion about maybe enhancing the model or something of that nature in the future. So now that I've helped you understand our structure for the model and its delivery, I'll go in a little bit more depth here with the system overview of what the system is for the port of Prince Rupert. I'm going to play a little video as I talk here. Marine fuel will be transported on existing rail infrastructure from Canadian supply locations to the port of Prince Rupert. They go to a yard. Eventually, they are brought to this Aquatrain dock that you see here, where a rail barge will come over and load the tank cars onto the barge. This rail barge has the capability to hold up to 24 different rail cars. Each of the rail cars may have different product of fuel on board, and they will be transported to the Wolverine dock, where they would be blended or transferred to the distribution barge. So this rail barge gets loaded up with those rail tank cars. They get pulled by tug all the way over to this Wolverine dock. Here, this marine berth or Wolverine dock, the rail tank cars will be drained and blended as needed to fit the requirements of the customers. And once the distribution barge arrives, which is the novel patented machine that they're using for their operations, that will be loaded and sent out to customers. Once empty, those rail cars will be returned back on the barge and be unloaded at the Aquatrain dock, where those rail tank cars will leave and head to the rail yard or back to their original destination before another set of full tank cars would arrive and keep the system obviously supplied. Marine fueling will be conducted at certain locations by Prince Rupert Port Authority. So once the distribution barge collected its fuel, it would go to many different locations designated where the customer would be waiting to be loaded with the desired fuel. And here's an example of the distribution barge loading up a customer once it arrives. And the distribution barge had requirements defined by Transport Canada, make sure that everything was done correctly and safely. If you're interested in more, you can go to wolverineterminals.com where you can find more about the project itself outside of what I will share today in my presentation. Okay. So you can see the overview of the system. There's many challenges with this simulation overall. To confirm the throughput capacity of the marine operation, there were some complexities that we needed to understand and talk through together with Wolverine Terminals. One, I think the big thing here is it's a new operation. There was no historical data set. So we knew we were going to have a challenge there, capturing the complete operation and coming up with an accurate representation of what the data might look like. And I know that we'll probably be revisiting in the future once we do have historical data and it is in operation. Also capturing the logic of and purpose-built infrastructure, the Wolverine dock and distribution barge, and the other equipment that's involved, such as the rail barge, the rail tank cars, the blending process, and those types of things. The demand, supply, and capacity constraints system are definitely a big concern, and you want to make sure you capture them adequately. The blending requirements to produce a finished marine fuel product is definitely complex, and the order of operations to complete certain tasks as the rail barge arrives at the Wolverine dock. Do you begin blending, draining, filling up the distribution barge? There's a lot of different unknowns that they're unsure of, and what would be the bottleneck and what is the best way to handle things. There's also things out of their control, such as weather patterns. There's also operational hours, daylight hours, seasonality to take into consideration, and tide cycles. So we want to make sure we include them as parameters in the model. And then also the inter-arrival of variability of vessels or customers and their limited berth duration, because the customers will only wait a certain amount of time before they're actually being serviced. So to make sure that they could serve their customers best and have the most maximize that throughput, we definitely had to take that in consideration. And having said all, the simulation model and results all need to be completed within 2 to 3 weeks when will reach out to us. They had a tight window to get this done and to get results from it. So we knew we were going to have to make some model assumptions to get this working correctly and work with them closely and quickly to deliver a quality product to them. Simulation components, we did this up front with Wolverine Terminals. We knew that FRS was important, that simulation specification. We do it through a document. There's many pages to the capturing the system itself, the architecture of the model, how we intend to model it. Then we also developed simulation front end, which is a user interface. It's developed in Excel, and it's defined in the FRS document, as well as a simulation model as well, which we chose AnyLogic because AnyLogic was such a great use case for this. It made development so much easier to be able to deliver this in a timely manner and have the flexibility for all of these complexities that we had captured on the previous slide. Oh, for the simulation inputs, like I mentioned, it is a user interface through Excel. I think I counted 154 different configurable input fields. We had barge attributes, product attributes, customer demand, external factors, weather, tides, etc., rail service capabilities, just to name a few. We had 21 unique time distributions, customer berth duration, how long they stayed, customer stem size, how big of a vessel the customer was to be filled. What are those weather disruption distributions we can use, seasonal operating hours, those kind of things. The additional benefit of this input in Excel was that we were able to have it also execute the model from within the user interface, where we have from MOSIMTEC to be able to run the model through the executable. That way, Wolverine Terminals could also run the model at any given point in time on their own machines if needed. And in fact, they did that quite often after we delivered the model itself. So user interface for simulation basically allowed the user to run the model from Excel, allowed the user to easily add, create, view, and update, or even delete data to create a model scenario through the use of inputs, and appropriately transform the data to simulation model requirements. It also provided the model with results in the interface, and I'll get to that for the simulation outputs. And this interface basically became a reusable template to run different scenarios and let Wolverine Terminals, come up with many different ways or however they could imagine running the model and testing different scenarios quickly and easily as possible. And like I said, it runs the model through the interface, so they would actually be able to see the model being executed and ran in real time if they wanted to, or if they wanted to create many different replications quickly. Simulation model overview. This is a diagram basically describing what was in the video, where on the left-hand side, you see the rail tank cars arriving to a rail yard. Eventually, those full tank rail cars come to the Aquatrain dock, where they would be transported by the rail barge to the Wolverine dock to be unloaded, where a bunker barge or the distribution barge would travel to locations and field operations to the customer. So we took this full system diagram and came to some modeling assumptions that made sense. And one of the things that we did was cut out the rail yard here to simplify the model. This way that we could just assume that rail tank cars were always ready and available for a switch. That way we could really see the maximum throughput of the system if we weren't always waiting for those rail tank cars to be there themselves. So taking that image and breaking into this smaller image, we can go into those key modeling assumptions. Like I said, we removed the rail car logic from the scope, assumed rail cars are always available during a rail switch. Now, the rail barge tanks, which is on the rail barge itself, where they are basically being drained and loaded from the rail tank cars, we track total capacity to simplify it rather than tracking each individual tank car. This would help us speed up some of the development. We also calculate discrete time for fuel transfer, rather introducing some sort of flow where, although it's accurate, the discrete times were considered acceptable based on the order of operations that occur here. And we can just simply calculate, what's the longest fuel transfer time to use. Instead of using specific locations of customers, we instead use zones to represent approximate locations of those customers. That way there was a distribution of time of that bunker barge or distribution barge moving to those customers and delivering fuel. The demand was also generated by an arrival rate, which we use. The disruptions that we mentioned earlier, like operating hours, daylight, impacted the delivery of the barge to the customer as well. And kept animation for this model to be mostly minimal. It wasn't a priority for Wolverine, as they were more interested in the outputs of the model, and that could always be revisited. So running the model, I'm actually going to share a example of the model running. Like I said, animation wasn't a big thing. This isn't anything fancy in 3D, but it does the logical components in place for how processes move forward for the rail barge and the distribution barge specifically. I'll go ahead and play this while I talk to it. So this is a 2D view. On the right, we have a blue rail barge, which is one that's picking up the rail tank cars and bringing it to the Wolverine dock. And then on the left, you have the green distribution, which is bringing it to the customers. The blue rail barge is going to go to the dock, pick up those rail tank cars, bring them over to the Wolverine dock, where they will do connecting, draining, blending if need be, while Wolverine dock is ready to load the distribution barge at certain times. We had a sure business rules when we can blend and when we should be loading that distribution barge effectively. And something that we can definitely play with in the future because the times were really important, and when they can occur. That move between the Wolverine dock and the trading dock had to take into consideration certain times of the day when it can actually do that due to the tides. And then on the left side, we had the the distribution barge, the green one, moving to the customers as needed based on demand and based on the product that was available at the Wolverine dock. The customer would, or the distribution barge would go to the customers in either zone A, B, or C. And just for simplicity, we can track how many customers were at each zone, what's in parentheses there, such as zone 3 had 3 customers waiting. At the top of this, you see we created a header bar, if you will, where we see the main animation of the model. We also captured statistics. Unfortunately, I can't share everything because a lot of the outputs are sensitive to our client with Wolverine Terminals. But I was able to show you the majority of what's occurring here. You can see the model time for this scenario has the seasonality included, the day and the hour of the day that we're in, so we could track that ran. I know that running pretty fast, but there's a lot of things that are occurring here, and we would run it for a season at a time for them, depending on what they're interested for each scenario. And yeah, that's about how the looked for running. Now, simulation outputs. The customer worked in depth during the FRS portion of the project, and we had about 36 requested outputs. Some of them that we kind of worked together to kind of figure out what made sense. They had an idea of what they wanted to see. Some of those key KPIs were total throughput of the marine fuel. Clearly, they would like to know that for the maximum throughput was their goal. We also track customer service levels. You know, were they meeting the customers in time? How soon were they serviced? Did we miss some customers based on their birth durations? And were we prioritizing them well? Also, the asset utilization, certain tanks being used on the rail barge itself or at the Wolverine dock. And we ran many different scenarios. The summary report, the simulation outputs, captured a number of different scenarios. We tested how each input affected outputs so that they understand the more clearly and best find what worked for them. A number of these scenarios ran for 100 replications, got the minimum, average, and maximum outputted, and it helped us to identify opportunities in the future once we started understanding some of the bottlenecks and things like that. So overall, the simulation from our point of view in Wolverine Terminals was seen as a success. It validated their throughput capacity assumptions based on those outputs, and once they reviewed it, they were able to take those outputs in Excel. They actually took some extra time to kind of create their own charts, which was further than what we did for them initially to make sense internally for them. This was actually from them. They shared that the reception was very positive across the board internally, and the model provided additional benefits as it became a tool for the team to understand the system constraints, identify those bottlenecks, test a number of what if scenarios and impacts to the various KPIs. Also assess their return on investment on incremental investments and prioritize operation efforts on the efficiency gains. So that's the end of a presentation. I'm looking into Q&A here. I think I have a few. So I'll go ahead and stop sharing my screen here and pull that up. Yes, so nice visualization. How did you do this? Well, I appreciate it. I think I definitely did minimal visualization on my end for the time constraint. I really used some of the built-in features of AnyLogic of using some 2D blocks to kind of give a general idea of what the port could look like. I was able to use engines for the barges to look like boats and represent as best I could in a 2D environment, and then just process logic for them to move across as they along their specific paths. And it just took some extra time getting things right by adjusting some of those images, and you weren't able to see it because I had a lot more statistics being shown as the model was being ran, but a lot more videos were there for you to see. And visualizations came out really good. And that header bar, I think that we typically do with all of our projects, gives it a very easy of use for the client, and it gives a good look overall for the model as it's running. Curious about your customer workshop. Was this like a one-day event with people from all functional areas, operation, engineering, IT? Good question. Typically when we do a project, they could be 2 to 3 days, and sometimes they're on site. The nature of this project had us working quickly, and we did everything in conferences. We worked in 1 to 2 hour workshop time. Jesse, who's not here unfortunately, was one of the leads on that, and him and I worked long hours to try to make sure that we have everything set in place. A lot of emails and sharing the document back and forth, which can be a little more difficult when you're not in person and sharing with everyone on the team, but it was a great point of contact and a great understanding. And if anything he couldn't answer, he would back and have a small team. Sometimes I would be including that, able to capture the information that we needed for the simulation itself. Is the customer continuing to use the model, performing their own analysis, or do you perform the analysis for Wolverine? Another great question. I did initial analysis for them. That's what we came to agreement on. But the nature of how we developed the model by using a user interface and having AnyLogic being executed on their machines allowed them to perform the analysis on their own at any given point in time. And Wolverine actually shared with me some of the charts that they used, scenarios that I didn't run for them. So they were able to perform analysis past the project timeframe, which was great for them, right? So that they could be able to go, okay, well, what about this? We're seeing this. They were able to use it up until I guess their operations are active here, and they can continue to use that going forward if anything has changed since we last spoke. There might be some things that might not be captured within the model. We try to provide enough flexibility for them, hoping that they can use it continuously. But they would come back to us. There hasn't been anything big enough for them to come back to us and say, hey, can we do some enhancement to the model? Because they didn't get the training to actually develop an AnyLogic themselves. And I think that's my time there. I think I had a side question there.